We have plenty of time to introduce the next speaker. I may even feel like reading his bio, but I won't. Okay. Next speaker is Mr. David Millar. He's the Vice President of Fugro Incorporated, and he's going to talk on Arctic information infrastructure, what's new, what's next.
Okay, thank you very much. It's indeed a pleasure to be invited to be here and speak to you today. I appreciate the opportunity to share some ideas that are coming from the private sector, and I'll be focusing primarily on hydrography and bathymetry in my presentation today. Some of what you'll see is a bit redundant, so I apologize in advance. The good news, I guess, is that I'm not at the end of the day tomorrow, in which case I would have no material left to show. I'm going to challenge you today to think about infrastructure to actually include data and information. So beyond the ships, the icebreakers, beyond the telecommunication and submarine cables, beyond the deep water ports and harbors, think of those infrastructure projects as also including data and information that are required in support of those infrastructure implementations, as well as the information and data required for us to make informed policy and management decisions. So you've heard this already multiple times. The Arctic Ocean, like all of the world's oceans, is inadequately mapped. The Arctic Ocean comprises of almost 16,000 square kilometers of water, of which only 6 to 7% of those waters are mapped to modern survey methods. And looking at the U.S. Arctic waters, there it's only 2.5% where it's been adequately mapped to modern survey standards. Senator Mikowski yesterday, I think, mentioned that's up to 4% now, but still we have a little work to do. These data are used to support maritime safety, inform ocean policy, guide sustainable use, improve ocean and coastal models, weather models, and identify future research, exploration, and development objectives. Looking specifically at the Arctic Ocean and the bathymetric or hydrographic data that exists, Larry showed some vessel track lines earlier today. This is from JEBCO. It's all of the data holdings in the Arctic. And you can see various ships that have been acquiring data, some single beam acoustic data, some multi-beam acoustic data. And clearly there is coverage. However, if you were to zoom in, you can see that they're largely single line data and by no means full bottom coverage. And as a result, we do have these significant gaps in data. And as a result, the low percentages of mapping that we have heard. Another slide that has been shown already is the opening of the Arctic shipping routes. And you can see on the left there that the traditional or historic shipping has occurred on the north slope of Russia through the Arctic waters. However, with the changing ice pack and opening of the waters in the Arctic Ocean, it is anticipated that in 25 years that a substantial portion of this shipping will occur through the Canadian archipelago and through the north slope of Alaska. You may have heard that we've mapped Mars better than we've mapped our own oceans, and in fact that is very true and sadly true. If we look at the world's oceans, most of what you see in the maps and the charts have been derived from satellite altimeter data. So it's remotely sensed data that is of very low resolution, 5-kilometer resolution, which means you have one sounding every 5 kilometers. So that's best case scenario. In many cases, it's 10 kilometers or 15-kilometer resolution. What's even more disturbing is that the absolute depth of that sounding could be an error by plus or minus a kilometer. That's true in deep water, obviously, but in deep water there can be errors on the order of plus or minus a kilometer in the bathymetry data that exists globally. Comparing to Mars, that data has been acquired from stereo cameras a 20-meter horizontal resolution, so you only have to go 20 meters before you get another elevation. And the vertical accuracy there is plus or minus 13 meters. So dramatically different. And the reason, of course, is that it's impossible to map the ocean floor using radio and other electromagnetic waves. So this is just the physics. It's a challenging problem, and here we are. We have not much accomplished and a lot to do. Fugro was involved with the search for Malaysia Airlines MH370 in the southern Indian Ocean, and I think this graphic kind of conveys the problem that we have, or the challenge that we have. The left is the existing bathymetry that has been derived from satellite altimeter data. And you can see some features there, but they are muted, not particularly resolute. And that was a real problem and challenge when it came to this search. It was actually impossible to commence a search for the airline and the aircraft prior to first doing a reconnaissance survey to understand what was the absolute depths and what was the topography of the seafloor to actually facilitate a high-resolution search of the seafloor. So that occurred over several months, and in the bottom right there is a graphic of the same area, and you can see just dramatically how different the resolution is. You can see features on the seafloor that you couldn't see before, and identify features, and in shallow water, of course, similar, you could identify hazards and obstructions. The good news is that there is a global push to map the world's oceans. This has precipitated quite recently. There is a JEBCO Nippon Foundation program called Seabed 2030 that was precipitated in June of 2016, but recently announced at the UN Ocean Conference in New York in June 2017. And the goal of Seabed 2030 is to map the entirety of the world's oceans to a 100-meter resolution by the year 2030. And that's a pretty bold endeavor, of course, and it will require tremendous resources and tremendous coordination and collaboration between scientific community, governments, NGOs, and private industry. Since the precipitation of this idea last June, Fugro has been involved with doing what it can in terms of at least getting the ball rolling. Fugro operates 50 vessels globally to support our engineering and survey activities, and we have started to collect multi-beam data, which is a sonar-based system on board our ships, and we've been collecting data as we move our ships from project to project and from continent to continent, with the goal to make this data available to the source. The challenge that we have on many of our projects is that we are working for customers who own the data, and it's their data and it's proprietary. So we have massive data holdings already, but most of those data belong to customers who own the data and will not allow us to share it. So we have also initiated dialogue with those customers and trying to communicate the importance of Seabed 2030 to those customers and explore their level of interest in releasing data that could be at a decimated level, so a lower resolution than it was acquired, or maybe temporarily delayed, such that the proprietary nature of the data and the sensitivity of the data might be minimized. So those discussions are in the works, and it's hoped, I think, one of the goals and objectives of Seabed 2030 is to firstly identify where does data exist. It's not just within private industry, of course. There's a lot of governments and navies that hold data that aren't necessarily sharing them yet also. So step one, to find and to try to then extract that data and then fill the gaps with new mapping. The new mapping itself, of course, is not trivial for the reasons I mentioned already. And that leads me to the Shell Ocean Discovery X Prize, which is another global initiative. X Prize, if you're not aware, is a nonprofit organization that manages and runs competitions that spur innovation and technology development, really for the benefit of mankind and humankind. Very interesting organization. They have financial support from Shell on this project. And the goal is to try to develop new game-changing technology to more cost-effectively survey the oceans autonomously and in very deep water as well. So I think we'll see some very interesting technology coming from this program. Fugro is involved as a partner with XPRIZE as well. We're providing the ground truth data to test all of the 20 teams that will be competing for the prize. There are regional strategies already in place for closing the data gap, and within the U.S. government at least, the mantra "map once, use many times" has been heard for the past decade and has been highly effective. Bathymetric data has numerous purposes beyond providing accurate depths measurements, and these examples include marine habitat characterization, inundation modeling, environmental baseline mapping, and resource evaluation and cataloging. There's also increased interagency collaboration. Very significantly, we see much greater collaboration and cooperation between federal agencies. By sharing the existing data sets, new acquisition priorities, and available funding, government agencies can better serve the public by meeting tomorrow's data needs with today's dollars. And I can say this program is even expanded to include private sector participation as well. So we are involved in terms of communicating some of our larger projects and extents of our projects to government, and making it, in many cases, even making introductions between government and our clients, such that hopefully that data could be extracted and brought into the U.S. government holdings and ultimately into the public domain. And the quintillion cable system that was referenced earlier by Elizabeth is an example. Fugro did the survey for that project, and we made the introduction between NOAA and quintillion, and the data has now been transferred to NOAA. Private sector partnerships. The private sector has a proven track record of teaming with academic and government partners to deliver technology innovations in acquisition, processing, and deliverables. I have three partnership examples here that might be relevant and of interest. The first there on the left is Seabed sea punting. Here we are actually utilizing some technology that was developed by NOAA at the University of New Hampshire. It's a multi-beam backscatter, and this technology is being used by the oil and gas companies in frontier exploration areas. And we're using multi-beam data, both the bathymetry as well as the water column and the backscatter data from these surveys to find areas of high probable gas reserves through the detection of seabed seeps. And these activities in a very depressed oil and gas market are rapidly growing. Despite the severe challenges that are faced in the oil and gas markets, we're conducting on the order of in excess of 1 million square kilometers of mapping a year in support of these seabed seeps. Another example is this project NOAA Penobscot Bay. We're working with NOAA for a hydrographic survey in Penobscot Bay. It's a very busy area with a lot of small fishing vessels and recreational boaters, but it's also riddled with literally thousands of islands and shoals. Very dangerous, and we're implementing an integrated approach that utilizes satellite-derived bathymetry, laser bathymetry, and multi-beam bathymetry to create a more effective and efficient and cost-effective approach to mapping this very challenging environment. And it's interesting that this methodology was actually pioneered and proven by Fugro in the Arctic first, and is now being used in other complex and challenging environments. Lastly, I'll speak here on an example with the Arctic Domain Awareness Center. Again, the presentation this morning referenced this study. It's a satellite-derived bathymetry study. We're involved with working with ADAC to, or will soon be involved with working with ADAC to try to identify where in Alaska satellite-derived bathymetry may in fact be feasible, and test the feasibility of using this technology for mapping the coastal areas of Alaska. So just, I guess, to reiterate some points that have been made relative to Alaska, coastal communities are clearly facing some changing ocean and weather conditions, making the need for accurate coastal mapping data increasingly urgent. Additionally, a significant portion of Alaska's economy is driven by the maritime transportation and marine resources, which also need accurate and updated coastal mapping data. Though the rest of the nation is served by the National Coastal Mapping Program, Alaska is not. So the lower 48 actually has a program to map the entire coastal waters on a regular interval. Alaska at the moment is not part of that program, and as a result there's really no coastal mapping that exists at a regional level in Alaska. And then lastly, I'll comment here, the Digital Coast Act was introduced in January of this year, co-sponsored by Senators Murkowski and Sullivan, and it seeks to fill these data gaps. The benefits of a well-mapped Arctic, again, probably reasonably well known to this audience, but firstly, safe navigation, provides domain awareness, first responders, Arctic shipping lanes, and insurance rates, driving insurance rates down for these vessels operating in the Arctic. Resource development, mineral leasing, exploration, development, as well as fishing, commercial sport fishing and subsistence fishing. Efficient infrastructure siting, fiber optic cables, pipelines, power cables, ports and harbors, all obviously require bathymetric data infrastructure. And then lastly, rate of change monitoring for coastal erosion, coastal protection, marine science and research purposes. So that's my last slide. If there's time for questions, I'm happy to take some questions.
Thanks, David. There's plenty of time for questions.
An old question, but an interesting one.
With respect to you, I have a question for the previous speaker.
Okay.
And he doesn't have to answer it right away because it's your time, but I'll put it out there. And the question is, how come Russia can afford nuclear icebreakers? So let's open it up to questions from the audience.
Why is Alaska not part of the mapping program?
This is a Corps of Engineers National Coastal Mapping Program, and the primary purpose of it, from the origins of the program, were related to, I guess, beach replenishment and shoreline monitoring. So the Corps has a program which is involved with finding sand sources and replenishing beaches, and obviously most of the beaches and most of the tourism that drives that program is in the lower 48, and unfortunately, as a result of that, that's where the program has been focused to date. But it is a concern, and as a result, Alaska is not getting the coastal mapping that the rest of the nation is receiving.
Thanks. Online again, can Phase 2 and Phase 3 of the Quintillion effort contribute to the need to provide additional mapping for some of the oceans? I guess Elizabeth or you could address that, but.
Yeah, so the question was, will Phase 2 and Phase 3 also?
Yeah, by default will contribute as well in the collection.
Yeah, so there's literally probably a dozen surveys that are occurring at any one time for these transoceanic cable routes. Yeah. And they were participants in the Seabed 2030 program, and they are part of the program. I think there is a recognition that the submarine telecommunication, submarine cable industry, and the surveyors that support it can make these data publicly available, and Quintillion was very good to step up and do that as probably the first example.
Fantastic.
Yeah.
Any other questions from the audience? There's one more online, and this one could be answered probably by by Larry, but again, can you think of any incentives to motivate Russia to publicly release more of their bathymetric data to improve IPCAO? Can you think? You may not be.
No, I think in general, it's not just Russia. I mean, there are many nations and there are many organizations that hold data currently globally that could be sharing this data for the good of mankind. And I think it will start with community education and outreach. That's a significant component of Seabed 2030, is to make really humanity aware of this massive challenge that we face in terms of an ocean and a planet that we really haven't adequately mapped, and trying to create some guilt in that process, and hopefully ultimately create stakeholders that are willing to share for the benefit of all.
Thanks. And not to put you on the spot, but since the next talk is about divining, this question is about divining. How much future bathymetric charting will be done by autonomous vehicles, particularly in shallow waters? Can you divine that?
I can say in general that full resolution, high resolution, full coverage mapping in the ocean has been expensive, and it's even more challenging in the shallower water. So it gets increasingly expensive as you get to the shallower waters. I would say that the technology that comes out of X-Prize's Shell Ocean Discovery X-Prize Challenge may crack this nut. I mean, the goal here is there's going to be 20 teams competing with game-changing, potentially game-changing offerings that could be deployed successfully and cost-effectively for deep and shallow water mapping. And we haven't seen those yet, but over the course of the next 4 months, we will have visibility on what those solutions might look like.
Fantastic.
Yeah.
David, thank you again.
Thank you.
And you do wear
I do,
glasses?
yes.